A very good time to all the viewers. We are going to present paper ID 1395. The focus of this paper is to develop a multimodal emotion recognition system for text and image, especially for the situations when training data is not available sufficiently. We will start the presentation by introducing the problem statement, then we will discuss the proposed approach, and then we will move on to discuss the results. When we attempt to recognize emotions portrayed by multiple modalities at the same time, one of the challenges that is faced is the unavailability of training data. We require training data having images, corresponding text, and emotion labels. So far, multi-class emotion label has not been explored completely. People have majorly focused on binary or tertiary sentiment classification, that is, to classify the images into positive, negative, or positive, negative, and neutral sentiment classes. That inspired us to develop a dataset containing multi-class emotion labels and then develop multimodal emotion recognition system. We have compiled a dataset that has multi-class, multi-emotion labels, that is happy, sad, hate, and anger. Then we proposed a novel deep learning based architecture to recognize emotions portrayed by text and images at the same time. The architecture of this system was determined through extensive ablation study, and thorough experiments have been performed. As discussed earlier, the existing research in context of image and text sentiment or emotion analysis focus on binary or tertiary sentiment classification. Multi-class emotion recognition into classes such as happy, sad, hate, angry, etc. have not been explored to its full potential. We have attempted to do that. To begin with, we first compiled a dataset containing images, corresponding text, and emotion labels. To compile that, we took raw data from BT4SA dataset, which stands for Balanced Text for Sentiment Analysis Data. It contained Twitter text along with corresponding images, however, without any emotion labels. We first employed a transfer learning based image emotion recognition model and found out the emotion class for all the samples present in BT4SA dataset. Then we used a pre-trained balanced net model, which is a LSTM based text emotion classifier model, and found out the emotion classes for all the samples with respect to text inputs. We retained only those samples for which the emotion class for text and emotion class for image came out to be the same. Those common predicted labels came out to be 97,170 out of total samples 1,21,805. So we released this dataset containing 97,170 samples containing text, corresponding image, and emotion labels. We named it Text and Image Emotion Recognition Dataset, that is TIER dataset, developed at our institute, IIT Roorkee. So the proposed approach includes a combination of intermediate and late fusion. To decide an appropriate architecture for this approach, we carried out extensive ablation study. We first check the emotion classification taking only images of the input. Then we checked the output emotion label considering only the text of the input. Then we used both of them. We used text and image information through intermediate fusion first, which combined the information from text and images. The intermediate fusion first fused the information from image and text and then performed the classification. We also used late fusion, which, as opposed to intermediate fusion, performed classification first and then fused the information. Intermediate fusion 1 performed intermediate fusion on text and image inputs, that is, it fused the information from text and image and then performed classification. Intermediate fusion did the same, fusion 2 did the same, while late fusion 1 classified the emotion labels on text and image separately and then combined the information using weighted average. Late fusion 1 worked on the outputs of image and text modules, while late fusion 2 worked on the output of image module, text module, as well as the output of intermediate fusion module. It was named as hybrid module because it involved intermediate as well as late fusion. Through experiment, it came out to be the best performing module. That's why it was implemented as the choice of the architecture for the proposed model. As described in the figure, the intermediate fusion works on the input of images and text, while the hybrid fusion works on the output of image and text module as well as the output of intermediate fusion module. Intermediate fusion first fuses the information and then performs classification, while hybrid fusion first performs classification and then combines the information using weighted average. During weighted average, the weight coefficients are found using grid search. These experiments have been performed on NVIDIA RTX 2070 GPU using a validation split of 0.3 and other settings as shown in this slide. Emotion classification results with accuracy of 90.20% were observed. We wanted to compare our results with existing approaches, but as discussed earlier, multimodal classification for text and image has been majorly explored in terms of sentiment classification. Multi-class emotion classification has not been explored that much. We used the proposed model for sentiment classification as well and observed the classification accuracy of 86.7% for sentiment classification, which is far better as compared to the existing approaches for sentiment classification. So in a nutshell, we proposed multi-class emotion recognition model based on hybrid fusion, which is able to classify the given pair of text and image into classes such as happy, sad, hate, and anger. Along with multi-class emotion recognition, it also performed better than the existing approaches for binary sentiment classification as well. The confusion matrix for the proposed approach is shown in this slide, and the next slide shows a few sample results. As we can see in the right top image, if we observe only the photo, it looks like just another metropolitan city. So predicting anger is not so obvious if we consider only the image, while when we consider the text as well, we can see that bombing is being mentioned, which should have contributed towards the prediction of emotion label anger. So qualitatively, it seems obvious that using the information from image and text modalities both helped us to come up with a better prediction for the emotion class. So in conclusion, we were able to develop a new dataset containing image, text, and emotion labels. We also developed a deep learning based architecture which involved a hybrid of intermediate and late fusion, and it performed quite well for multimodal emotion recognition for text and image inputs. And the hypothesis that taking information from text and image both might improve the accuracy of classification was also proven to be right through the results. In future, we would like to work on more modalities such as speech and videos and try to improve the results further. These are the references. We look forward to see you during poster presentation as well. Thank you.